And now, an exclusive sneak preview of a recent X-Talks webinar, Unparalleled Peptide Library Production, Automating High-throughput Peptide Synthesis and Purification.
That's very interesting results. I had a suspicion that most of you were ether precipitating your peptides, but trust me, there might be a better way that we'll talk about in a little bit. But before we get too far into that, I'd like to just kind of review kind of where expectations can be when it comes to purity and what those assay requirements actually are. I remember in graduate school, we HPLC purified everything because it was kind of the only way to get reliable results that you could actually interpret and draw conclusions from. But there are strategies and technologies and softwares that can help digest these data and from some of these assays that simply doesn't require 95% purity to be manageable and interpretable. And some of those types of applications and those assays are listed here on the right-hand side. And you can see relatively low purity. So certainly crude can be an option, or maybe something partially better than that. And some of these purities can even be achieved by just working hard on synthesis and depending on the complexity of your peptide sequences. There are certainly cases where we're still going to need those levels of purity, but as far as I can tell, and from the groups that I've worked with and spoken with so far, these lower levels of purity really are acceptable, especially for those preliminary assays and yes/no questions that we were talking about earlier. So we started asking the question as we were working with more and more groups trying to synthesize, 96 or 192 compounds. Are there another way that we can help manage these plate-based synthesis downstream? And so there's a couple different strategies that are in the literature that we were starting to think about. And the beauty of these things is they can be run in parallel, which simplifies the handling and the processing required for each of these compounds. But importantly, they also have the potential for automation. And that alleviates a lot of the stress that can be applied for your team members who, again, really want to be spending more time in the analysis and design phase of the workflow and not sitting in front of an HPLC. So those two strategies are shown here, where we have an SPE type purification, which I'll get into in a little bit. But then there's also these options for some of these catch and release type technologies, more in line with like an affinity type chromatography or even a covalent capture. And when we started thinking about SPE, it really comes from my interactions with my colleagues on our analytical team who work in the sample prep field. And they're working primarily with clinical diagnostics and toxicology chemists. And they do SPE or solid phase extraction ahead of LC-MS analysis of all sorts of weird biomaterials. And what we were thinking about from a synthetic perspective is there are really some criteria that we have to be able to address consistently in order for this to become a technology that people will actually use. And those three criteria are shown here on this slide. The first and most important thing, as far as I'm concerned, is we have to be predictable. There are strategies and computational tools that will predict your HPLC behavior based on the sequence of your peptide or related compound. We can certainly use analytical data, but we're trying to avoid running 96 HPLC injections at this point. So anything that we can use from a theoretical perspective, we have to be able to predict how those compounds are going to behave. Because remember, now we're treating 96 compounds, 96 different compounds, essentially as one. The other thing, the next thing and most important one is the recovery. So we have to be able to get back a significant proportion of the amount of material that we loaded onto that plate. If I load 2 milligrams of purified compound onto these media, I need to know that I'm going to get 80 to 90% of that material back in order to have enough compound to perform the assays in the next steps. And then the third step really became more of a product question, and that's sample load. So there's a lot of materials and a lot of medias that are commercially available already today for the use of solid phase extraction or SPE, but those are typically targeted towards those diagnostics, those toxicology, those forensic groups where they're using like nanograms to micrograms of material that they're being retained on this media. And that's just simply not sufficient for a synthetic lab where we need to have milligrams of material loading capacity for each of these to handle all these compounds. So that's a different question to be asked, but I think you'll see that we've got it kind of pretty figured out.
To view the entirety of this webinar, visit the link in the description and register on xtalks.com completely free of charge.